This question asks how many milliliters of 0.75 molar sodium hydroxide are needed to neutralize 275 milliliters of 0.50 molar nitric acid. So I can underline my quantities here to help me get started. Sodium hydroxide is 0.75 molar, but that's all they give me. They only give me a molarity. I don't know the volume. I'm trying to find out how many milliliters of it. I do know both the molarity and the volume of the nitric acid, so that's how I know I've got enough information to start this question focusing on the nitric acid. And then I'll convert it into moles, use my mole ratios, and eventually figure out my volume of sodium hydroxide. So just like before, we're going to start off with step one. We've got a molarity and a volume, so we can use that to find our moles of the nitric acid. Convert your milliliters to liters. That's given me about 0.138 moles of nitric acid. This reaction is already balanced. It's just 1-to-1 ratios. So I'll divide by 1 and multiply times 1. It would make sense I would have the same number of moles for each of my reactants. So from that, I know I've got the same number of moles of NaOH. I'll just write it there as a step. And then finally, I need to get my final answer. Well, I know my molarity, but I don't know my volume. So this time, for my final step, I'm going to use the molarity equation again, and I'm going to be trying to find out how many. First, I'll find liters, and then I think I'll convert it to milliliters for the question. Well, it looks like to find liters, I would divide moles over molarity. In this case, that's going to be 0.138 moles over 0.75 moles per liter. Molar means moles per liter, and that's why moles and moles can cancel to give us an answer in liters. So that's about 0.184 liters. They want an answer in milliliters, so I'll multiply times 1,000 and get about 184 milliliters. I guess I should probably go with 2 sig figs for my final answer here. So I'll call it 180 milliliters of 0.75 molar sodium hydroxide. All out of room. There we go. So that's how we could work a problem with solution stoichiometry, and we're just using the molarity equation on both ends of the stoichiometry problem. It's just one more way to get in and out of moles.